All right, let's get started a bit early, so we have more time for questions after. So my name is Otto. I'm a serial entrepreneur and Scala developer. I've been using Scala for the past 4 years. Before that, I was mainly using Java, C++, the usual stuff. I come from Finland, and in my company we have been using Scala, like I said, for 4 years. We switched over from Java, and there's no going back to Java after you try Scala, as you probably know. For the past 1 year, I've been also involved in the scala.js, so we used to do our front end in JavaScript, as most people do, but now we've switched over to scala.js because it saves us the trouble of doing any JavaScript development. And I've also been quite active in the scala.js community, building some libraries, doing tutorials, also revamping the whole scala.js website. So it's really great technology, and I hope you'll find it useful after this presentation. So what is scala.js? It's basically a compiler. You write Scala just like you would normally, and then you compile it to JavaScript, which you can then run in the browser. It has full support of the Scala language because it's actually using the same Scala compiler as you would use when compiling the JVM. It just outputs, instead of bytecode, it generates JavaScript. So you get all the same benefits of the Scala language as you would in other environments. But it also has full interoperability with JavaScript. So as you know, there's a lot of JavaScript libraries out there. If you need left padding or some other things, there's a library for that. But there's also a lot of great JavaScript libraries for front-end development, like React or Angular and so on. And Scala.js has been designed to work with these libraries from the very beginning, so you don't need to do any special things, but you can actually use these libraries, call them as you would call any Scala code, just by writing some nice little facade for the JavaScript side. And the compiler is very good at optimizing your code. If you're worried about compiling from Scala, which is like very complicated compared to normal JavaScript, you don't have to worry too much. You can usually just write Scala as you would writing for JVM, and the compiler will take care of all kinds of optimizations. It's actually doing a bit more optimizing than Scala C, as we will see later on. And in the JavaScript world, in front-end development, people are always worried about how big is your JavaScript size. Is it too big for, let's say, a mobile web application? But the JS code generated by Scala.js is, let's say, small enough. It's not as small as you would do it if you would do everything by hand, but it's small enough for practically all use cases. And finally, if we all know that Scala is not the fastest compiler around, and if you add JavaScript compiling on top of it, it doesn't really get any slower. We will see soon, as I do some live demos, that the normal edit compile run cycle is very fast. It's about as fast as you would get by just using JavaScript and the normal JavaScript tool chain. But let's do a quick live demo to see what it actually looks like to do JavaScript in Scala. So I'm going to be using this Scala fiddle, which originates from scala.js fiddle created by Howie, who has also done a lot of other interesting Scala.js libraries. So basically the Scala fiddle is a browser application that has a server-side compiler. So you write Scala on the browser, and then it compiles it on the server side to JavaScript, and then that JavaScript is actually run in the browser. So let's make some simple code. So you can just use normal Scala code, press Ctrl-N, Ctrl-Enter, it will then compile it on the server side, and then the output is JavaScript, which is then run in the browser. So let's make this a bit.
Can you make it bigger?
Yes.
Bigger?
Can you use source the JavaScript on the thing?
Huh?
Can you use source JavaScript on the thing?
Yeah.
The JavaScript on the thing. Can you use source the JavaScript?
Well, the source code of the JavaScript is like 3 megabytes, so I'm not going to show it here. Because this is in the sort of fast optimized phase when it doesn't optimize the size yet. We can see some things later on, but basically the JavaScript it creates is quite readable until you run it through the Google Closure compiler, which sort of minifies it, and then it's totally unreadable. But that's what everybody's doing in the front-end world anyway. But let's create some actual HTML. So I'm using a library called Scala tags, which enables you to write HTML in Scala just by defining these tags, and then I need to render it to be actual DOM element. I have this support utility class called fiddle here, which allows me to, for example, put that element into the DOM. I also have full completion, like I can write print, and then I get this. It actually goes back to the server to ask that, what can I fill in here? And then it gets this list like you would get in an IDE, and then you can just write print.
Does it use the compilation compiler, or?
Yeah, it's using the same stuff that's in Scala 2.11.8 as a new completion mechanism. So it's basically the same as the REPL is using. And but let's add some other things here. And there's a panel, which is actually, as you can see, it's a div element within that output window. And in the panel, I can just use normal DOM. If you're familiar with JavaScript and DOM, you know that this DOM is built by using these app and child calls. And let's add it that way. So this is pretty similar as you would do in normal JavaScript. Let's add another text box, just an input element with a render. And let's add that one there as well. Of course, normally you would not individually add these like this, but you would build like a one div. But because I want to access that header later on, I want to have it in my variable. Then I'm going to add event listener. It's going to get an event. I don't care about the event type, but within the event, so whenever okay, so now I have this input box here that I can write something. So whenever I update the input box, this callback is being called, and then I can use it to set the color of the header to whatever I write there. And I can also demonstrate that if I make some mistakes, like use the British color, which is of course a huge mistake when doing programming. So you get the error messages here very quickly and easily. So it's not an IDE, but you can do simple stuff here quite easily. So now if I write some colors here, I can see that whenever it's a valid color, it will create change the color to something else. Okay, so this Scala fiddle is actually meant to be as a sort of tool for exploring Scala. So it's not just for scala.js, but it's going to be a Scala Center project. So it's something that you can embed on web pages. So when you have, let's say, a library and you want to document your library, you can bring in this kind of interactive documentation that you can show some examples and let people who are reading your documentation actually experiment it with. Because this is full Scala compiler in the backend, you can do all the stuff you can do normally in Scala. There are some limitations, like you can't use reflection and some other things that don't work in the JavaScript world, but otherwise it's a very nice tool for doing these kind of simple examples. I can also show you that I don't have the JavaScript code, but I can see. So this is actually the code. So there's a template in this fiddle that I'm just writing in the sort of whatever goes into the main function. But there are all the normal imports and some other things wrapped around this thing so that it actually makes a full Scala application. You have to have that JS app there, and it actually is a normal JavaScript application that you can run here. And it also shows you that what libraries I'm using here. But let's look at a bit more complicated example. So this is a Hilbert curve, if you are familiar with that. So this is just a normal plain Scala algorithm for drawing a Hilbert curve. Okay, and then I have this loop here that every 100 milliseconds draw the next path in the curve. So I can make this a bit faster. You don't have to wait for it. Okay. Done something wrong. Let's reset. And this reset function here. So now it's going a bit faster. So this is also a good way to, if you consider that you are usually using like REPL and you are just generating some text output, like you get the result and the type, which is quite ugly usually. But if you want to demonstrate some features of Scala or your library, you can also use all these kind of graphical elements in the Scala fiddle. So this is one of the sort of benefits of having JavaScript support, that you don't have to rely on people to download Scala, install SBT, run REPL, then try your examples there, but you can just give them direct access on your website to try your library or your examples. And let's leave that running in the background and let's go back to the slides. Of course, being Google presentation, it always wants to download it again on a presentation. I wonder if they have any kind of offline mode for this. But maybe we'll just use this. Right. This is why I usually don't trust like all the fiddles I'm running on local host, because I don't trust the network to work. But I haven't figured out how to export like a local. I have a PDF as a backup for the presentation, but let's hope we can get. Maybe you guys are just using all the bandwidth.
Use download cursor.
Yes.
Okay, this is embarrassing.
I think you better switch to the PDF.
Yeah. Okay, we are back. Let's download the PDF at this point. This thing happens next time, right? So let's look at the internals of what happens inside the scala.js compilation pipeline. So this is the normal Scala compiler compilation. You have a source code, you run it through the compiler, you get a class file, which is JVM bytecode. You pass it on at runtime to JVM, and the JVM then pulls in all those other libraries from jars, and then that's your application. In Scala.js, you start with the same source code. You run it through the same Scala C compiler, but there is a plugin, ScalaJS plugin, that actually instead of just generating this class file, it also generates this scala-js intermediate representation file, which is like something that will then be converted to JavaScript later on. The idea is that when you have libraries, Scala libraries that you want to use in scala.js, you have to have these intermediate representation files in the library, in the jar files. So basically you need to recompile Scala libraries so that they can be used by scala.js because it needs these higher files in the linking phase. So this is a bit similar as was discussed earlier about the Dotty compiler, that there is this linking phase as well. So instead of doing the, let's say, linking at runtime, it's done in the compiler. So everything you have, the full application is actually being built at this phase. So your code is being included, the library code is being included, and then it generates this huge JavaScript file, which is then your application. So this is a bit different from normal Scala compilation cycle, but all of this is also incremental compilation. So when you make changes, it doesn't do everything again and again, but it's fairly fast. As you saw with the Scala build example, you didn't really see much of a delay when changes were made in the source code. And it also does a lot of optimizations. Like if you had been using scala.js like 2 years ago, it would be generating these huge files and it was really slow, but now it's actually doing a lot of optimizations that help producing very fast JS code. So the original, let's say, compilation and linking step generates this very big JavaScript file, mostly because the standard library, the collections are huge, they are not modularized yet, so everything gets pulled in. So if you use one list, one sequence, everything in the collection library gets pulled in, resulting in this huge file. But it does full program optimization, so because it knows your code, you have to actually tell it the entry points, and this is where my code starts. And then it will sort of go through your code and see that what code are you actually using and what you are not using. And then it's just removing all your unused code. So instead of, in the JVM world, when you build a normal Scala application, you usually end up with something like 30 megabytes of jar files. But in the Scala.js, everything, all the code that you are not actually actively using in your application gets removed. And this sort of results into this 1 to 2 to maybe 4 megabyte JavaScript file, depending on the amount of libraries you're using. And this is the normal development time of compilation. Like you don't need to optimize it any further. Now for production, you typically want to run it through Google Closure Compiler, which is done automatically by scala.js plugin, which will then result in a very much smaller JavaScript file, which is totally fine for all kinds of uses. So why is scala.js important right now? Well, we know that front-end stuff is getting complicated. If you look at the old stuff like 10 years ago, it was really simple. You were just producing HTML files and maybe a little bit of JavaScript to do some animations and stuff like that. But it was all on server side. Nothing important was happening on the client side. Then the next phase was that people realized that, hey, I can do more stuff in JavaScript. So this kind of idea of single-page app was born, that like Google Gmail inbox is a sort of typical example that everything is actually happening on the browser side, but you still have these HTML templates and calling REST APIs over the network. And people got more greedy and they wanted to be even more JavaScript centric. So even more complicated applications were born, and you were not using DOM, you were not using HTML anymore, but you were using code to generate the DOM. For example, Facebook React is a typical example of this kind of library, or Angular 2. So it was getting more and more complicated. You had more and more files on the front-end development, and also you started using new features that were not supported by the browser. So you had to use these transpilers, Bubble, or TypeScript if you wanted to introduce some types. So also the whole compilation pipeline on JavaScript world changed. It was not just you had JavaScript and you upload it to the browser and it was fine, but you had to go through the same compilation pipeline as you would in server-side programming. And then the next generation that we are now seeing is basically you have all these new languages coming up like Scala, Clojure, Elm, TypeScript, that people are starting to experiment, not just using JavaScript, but using other languages as well. And sharing code between client and server. Of course, the JavaScript developers want to see JavaScript on server side, so they created Node.js, but now Scala.js allows you to use the same code on server side and on client side, but it's instead of being JavaScript, it's actually nice and clean Scala code. And in a sense, JavaScript is being reduced as a sort of bytecode, and they are doing these web assemblies and so on. So it's more like a compiled target than a native language. It's not like people are writing code in assembly language these days, but you have a lot of compilers generating that. So why would you want to use Scala.js instead of normal JavaScript? Well, we all know it's strongly typed to catch the errors at compile time. I don't need to maybe tell you all this because you all know this already. But in the JavaScript world, you do a lot of runtime checks because you cannot do compile time checks. You don't know the types to compile. There is no compiler, so you can't do anything there. So you need to either do a lot of testing in your code base just to catch errors that you would catch at compile time in other environments. Or at runtime, you have to verify that is this still valid, is this a string, is this that and that, which you don't need to do with Scala. Because Scala.js is compatible with all the Scala libraries, except the ones that depend on Java library, because it is not going to be compiling Java code in Scala, so you have to have like a pure Scala environment, except some Java stuff, like the normal runtime stuff, has been converted to Scala or Scala.js. But you also get to access all the existing JavaScript libraries, and this is a huge bonus for development. You don't need to create all this stuff from scratch, but you can just take Facebook React, use the facade created for that, and just start writing front-end applications in Scala using these developing and great libraries out there. And you can run the same code on server and client, which is quite useful, especially when it comes to server-client communication. You don't need to rely on just using JSON and so on, but you can do this kind of real RPC. And of course, you don't need to write JavaScript. This is, in my opinion, the biggest benefit of Scala.js. So let's look at the strategies. This is the sort of classic strategy of doing front-end. You have the server side rendering HTML, and the browser is just displaying the HTML. This is how everything was done for a very long time. And then you get this front end being developed in JavaScript. We're using REST API, but you still have the server side in Scala. I guess like Wix is using this kind of strategy for your stuff, and this is probably the most common one nowadays. With Scala.js, you can basically replace your front end JavaScript with Scala. And with that, you can get benefits like sharing code between client and server, having a more like RPC API that you can do this, like in the microservices where you can call microservices directly by using Scala APIs. Okay, let's look at another live demo. So this is a tutorial I made about a year ago when I was learning Scala.js myself. So it's available on GitHub, well documented, and it sort of demonstrates some of the typical things you would do in a Scala.js application. So let's look at the code a bit. So I'm now focusing on the sort of client-server communication and how it's done in Scala.js. The tutorial, the SPA tutorial is using a library called AutoWire, also by Hao-Yi, who has been super active in ScalaUA.js. So it allows you to define an API, just a trait. You have these functions, methods there, and this is the API between client and server. Then on the server side, can everybody see this, or should I use even bigger font?
There's just a presentation mode.
How much is the present?
It's not a map.
No, sorry.
No. Yeah, okay. So this is now basically the implementation. So to implement this on server side, you just extend the API, just like you would normally. Nothing, you don't need to care that you are actually being called by the client over HTTP. So you just define the functions, and that's how it goes. Then on the client side, where is my client going?
One, I think.
Okay. Now on the client side, to call, let's say, that get-to-dos function, we have defined an Ajax client, which is basically the AutoWire thing, and we tell it that, okay, we are using the API trait here, and then it will actually use a macro to generate code that will then do the call. So you can just call a method. You still need to do this .call method after that, but we can see that the result of this call is a future. So you just make a call on the client side and you get a future of the result. So whenever the call is actually completed, then the future gets completed, and then you can do whatever you want with it, like using the map call to create this update all to-dos. So this is the same thing over here. We are updating to-dos with an item, so we can just pass parameters here. If I make any kind of mistake here, then the compiler will compile. Compiler will complain, as will the IDE. So when, let's say, when we do refactoring, which is what we always do, then it affects both your client and your server. So when you change the API, which I can actually do here, let's make a mistake, and let's say that this is welcome now. And now we can see, let's change something that we can actually see. Get to-dos from server. So if I change the API, I can immediately see that, okay, this is now wrong. That there's something went wrong. So I can just fix it like that. The same thing on the server side. It also shows here the error. So when you make this mechanism sort of ensures that your client and server stay synchronized. So when you make changes to the API, it will refuse to compile the client and the server unless they are fixed to whatever changes you made. Let's go back. And this is not like a feature of Scala.js. This is just a library how you created for this purpose. It just makes it easy to do this kind of RPC. You can do it in whatever way you want, but it's one of the good things of Scala.js that you can actually access these kind of type-safe remote calls. And this is like the implementation that here, the way the call is actually being done is basically we are calling Ajax host as a JavaScript, and we are using this pickling library to create a binary form, so it's sending binary data to the server and receiving binary data, which is then extracted to the structure that we actually want. But this is also something you can override, that if you want to use something else, if you want to use WebSockets, this is where you can just put it. But you can check out the SPA tutorial for more details. Let's get back to the presentation. It's still available, yes. Now, so scala.js is a great way to do front-end development on the browser. We've been using it for quite some time now successfully, and a lot of other people and teams have been using it, and they have been very, very happy about it. Even people who have been doing JavaScript previously have been able to use scala.js because one of the reasons is that Scala, in essence, is quite similar to JavaScript. It's not like, let's say, ClojureScript, which is based on Clojure, which is more like Lisp. It's totally different from JavaScript. So for a JavaScript developer to jump to ClojureScript, it's like a huge leap because it's totally different. But you can start, just like many of us probably started writing Scala by just writing Java and then maybe using some of the Scala features. You can do the same thing with Scala.js. And if you have JavaScript developers, they can start writing Scala in a very JavaScript way, and then just expand over to the more Scala-ish features over time. But now that we actually have JavaScript, it allows us to do more than just basic browser applications. We can also do front ends for desktop and mobile. There are a couple of libraries that allow you to build native desktop apps with JavaScript. There is this NW.js and Electron, and they are of course based on the idea that you can run JavaScript, and they're using Chromium, like the browser, and Node.js, and to bundle all that into a desktop app. And if you're using Slack, for example, on desktop, that's a typical example of these kind of applications. And the benefit is that you can use basically all of your UI logic, UI code, both on the website, but also in the desktop. So this is, instead of using, let's say, Swing or some other Scala Java library to build a desktop app, you can just use the web technologies quite easily. Another way to do like mobile development is to use React Native, which is a system built by Facebook that's based on React. It's not using web DOM or anything like that. It's actually a native application on your iOS or Android phone, but it's using the same React system. It's using JavaScript to control the UI. So this is another way how you can write Scala applications and just run them on mobile. There are a couple of examples of how this React Native can be used with Scala already out there, and it seems to be quite easy to use. One other thing that I wanted to address is that in some cases you just want to do something quite simple, and you don't want to host a server to do that, or if you're worried about scalability, you really need to build a complex scalable server. How about doing web apps without any kind of server? So instead of doing this front-end server division, you can do front-end, or let's say you can move more and more functionality into the front-end because it's in Scala. You can just run the same code over there, and then instead of having a sort of huge server-side thing, you can just use things like AWS Lambda, where you're just doing very simple calls. You're doing a call, and then the Lambda will then run your code for just that one call, and then you can access some databases or so on. Or in some cases, you don't even need this, that you just have some functionality you want to expose, and you can do it all on the front-end side. Let's say you have some financial institution who wants to do some simulations. You can then just do those simulations on the front end in JavaScript world without worrying about having a server for that. And you can even move a bit further. Because the Lambda is, even though it supports JVM, then the startup times are not so great because loading JVM and all that thing that happens in the beginning is quite slow. But if you also compile your server-side code into JavaScript and use Node.js, then you get the benefit of really quick startup times and also faster execution in the Lambda. Because the Lambdas are typically very short-lived calls that you call a function that just goes to a database, fetches some data, and maybe gives it back or something like that. So you don't need to have this huge JVM to be restarted on almost every call and so on. So this is one way of writing Scala applications and running it in JavaScript, both on front end and back end. I don't know if anybody has actually done that, but there's been some blog posts about this using Lambda with Node.js running scala.js applications. So here are a couple of examples I collected of what kind of applications have people actually developed using scala.js. There's Querki, which is a sort of wiki kind of thing, online information tool, developed by basically one guy, already almost 10,000 lines of code. There are a couple of other examples. I mean, these are pretty big applications, and these are all made in the last one year, one and a half year. So it's possible to get your team quite quickly up to speed writing large and complicated applications in scala.js. For example, network management graphical UI used to be like a Flash application before, and now they have written it into real web application using scala.js. So in summary, scala.js is production ready. It's basically been production ready for the past year already, and it's been evolving all the time. Now the focus is moving more towards how to integrate even better with the with the JavaScript libraries and the JavaScript compilation techniques. There are all these webpacks and browserifys and other NPMs and stuff like that you have to consider when you are really integrating into the JavaScript world. But most of the compiler is ready. It works very well. It even supports Scala 2.12 already, so you don't need to worry about getting left behind if you choose scala.js. Developing is very nice. You can just use your normal Scala IDE, whether it's IntelliJ or Eclipse based, and all the tools work just as they would otherwise. These IDEs don't really even know that you are doing Scala.js. For them, it's just normal Scala code that gets compiled a bit differently by the plugin in SVT. And I'm still emphasizing this integration with the JavaScript libraries because it's a very important part of this, especially if you have a team who have been using JavaScript libraries, who have been building frontends using those libraries. Then they can continue using those libraries. You don't need to step up and sort of create a new library for just called scala.js, but you can just keep on using those existing ones and reaping the benefits of all the developments that happen for those libraries. For example, React, just a new version of React was just released today, or was it yesterday? And we've seen that a lot of Scala libraries have been also ported to Scala.js. Typically, if you have a normal Scala library that doesn't have a lot of dependencies or doesn't use reflection, you just have to enable like one plugin in your compilation build file, and then you suddenly have a Scala.js compatible library. So we have seen examples like Cats, Scala-Z, Shapeless, Scala-Test. All of these sort of, let's say, big mainstream libraries are already working on Scala, on top of Scala.js as well. And there are also a lot of libraries being built, especially for Scala.js use. For example, Scala tags, upickle, Dio is one of my own libraries, AutoWire, all these things. So the ecosystem is moving ahead quite quite nicely, and a lot of people are publishing their libraries as open source. If you want to get started, just head out to the scala.js website, and we also have a Git room with about 800 people there, so just sign in there and start asking questions, and there's a lot of people willing to help you out. You were really quick.
I have two questions. First, first I want to use NPM, so I can use Webpack or Verify. Out of the box, they support transform to scala-js support. I want to use one NPM, for example. So Webpack support, using it for scala-js.
So using NPM?
Yes, I want to get an NPM from the internet and use it to my scala-js code. Is it possible?
Not at the moment. So the thing is that the compilation or the bundling phase is the problem, because scala.js is basically building a single JavaScript file, which is your application, and then the dependencies are basically bundled separately into another JavaScript file. But the method at the moment is that they are just in a global scope as they used to be a long time ago. So what needs to be done is basically to run another step that would then run it through these module bundles, so that whatever scala.js is producing is like one module that then gets integrated with all these other things. But the problem is that in development mode, I've actually tried this myself already, but the problem is that when scala.js generates that 4 megabyte JavaScript file and you give it to Webpack, it sort of waits, does something for 10 seconds. Even it doesn't need to do anything, it just takes 10 seconds to go through that file. So then suddenly, when you're used to having like half a second compile cycle, then you have these 10 seconds extra. So we have to figure out that how to get around that, maybe replace these Webpacks and other things with scala.js internal bundling mechanism. But that's actually one of the big things for scala.js 1.0 is to get this module bundling so that you can just use the NPM libraries. Because many of them are now only in this module formats that you don't get the sort of ready compiled versions anymore.
One question, you mentioned React, and I was wondering, you get the React and render it on the client side. Do you have ability to support to render on the server side, the React, or?
Well, I think the current version of the facade that sits on top of React, it probably doesn't work on the server side, because basically you would need to render to a string instead of a DOM.
Yeah.
It's totally possible, but I think it's currently not.
For SEO and so on, SEO views and so on. So
Yeah.
because you know we're doing it, so not
Yeah, but that's something that's being discussed quite often on the GitHub channel, that it's a known issue, and that it's just that there's this one Australian guy who is doing the React facade, scala.js-react, and he's working on his own project as well, and he's like one guy doing all of this on his own, so it's not a top priority for him at the moment. But there are some other React facades as well.
But you're not running anything on the server side with JavaScript, only in Scala, and you produce a file.
Yeah.
Okay.
Yeah.
No like Nesron running or something.
No. There's nothing. No JavaScript is needed except when running tests on the server side. Then you typically run the tests in Node or the scala.js.
Can you show an example of tests if you have? If not, okay.
No, well, I mean the tests are the same as in. You can run the same. For example, in my library, it's one set of tests. You run the same tests on JVM and on JavaScript using Node. Let's take over there first.
Okay.
Is it easy to debug over time? For example, what about source maps?
Yeah, I forgot to mention that the scala.js compiler produces source maps, so you can actually do debugging in Chrome dev tools, just like you would do with Elm or TypeScript or one of these other transpiled languages. So it's not, of course, the debugger is not as powerful as in your IDE, but it's good enough. And usually you don't really need to do that much debugging. It's not like in JavaScript you have to do a lot of debugging because everything happens in runtime. In Scala you have that compiler taking care of most of the problems, and you don't. For example, I very rarely need to do any debugging with scala-js.
Just saying that.
Ah, okay. Over there?
Hi. So, JavaScript ecosystem is really big. We have tons of libraries of different kinds. And when you signature, you know absolutely nothing of input or output types. What is the common approach of integrating stuff with ScalaJS? Because that ScalaJS is cool. But when you try to integrate, I see just a big mess of matches.
Yeah, so one approach is that, because a lot of libraries nowadays have TypeScript definitions out there. So there's a tool that generates scala-js facade from a TypeScript definition. It works like, let's say, 95, 98%, so you still have to do some fiddling with the code. But basically, if you have a TypeScript definition, then you can use that to bootstrap your scala.js facade development. If not, then you have to go and look at the code. Or, well, because you don't need to do facade. If you want to be untype safe, then you can use the dynamic typing in Scala as well. You're just writing like JavaScript, that the compiler, everything is fine with the compiler. It just generates similar JavaScript then as an output. You don't get any type checks or anything. Yeah. But that's a good way to sort of start to just experiment with something, and then when you get that working, then you can build the facade when you know the types and so on. And also, if you have a complex, let's say, for example, in my tutorial, I'm using this chart.js library, which has a lot of different charts. But you don't need to build facade for all of them. You can just cherry pick. I need a line chart. I need a bar chart. So I just basically wrote facades for those features that I need. And a lot of these facades have actually been developed like this. But you just start with the features that you need, and then you can go and expand over time.
My question is also about server-side rendering. Maybe is there any library except React to have an ability to render on server-side? Do you know some examples of somebody using server-side rendering?
Yeah, for example, the scala-tags library that I was using in the example has server-side rendering. So on the client side, when you call render, it generates a DOM tree. But on the server side, when you have exactly the same code and call render, it generates a string of HTML that you can then export. And basically the same thing would happen with the React as well. But I think that with the React, there is just some minor things that would need to be changed for it to be able to react, to be able to render on the server side as HTML. But for example, the Scala text library was originally created for server-side rendering. And then the second phase was the client-side stuff with scala.js. So it's definitely possible. Anything else?
Those type annotations or type wrappers we need to write in order to use JavaScript libraries. Do they add any kind of performance or space penalties in runtime?
No, the facades are transparent in that sense that they are like compile time only, and when the JavaScript is being created, it doesn't do any type checking or anything like that at that phase. Of course, when you are doing Scala code, you still have those, let's say, pattern matching. There is still some runtime checks, but with the JavaScript library facades, there is nothing. It's as performant as it should be. Yes.
What about for browsing? What about for browsing? It generates some JavaScript. Is it modern or ES5 script?
It's ES5 compatible. So the scala.js generates JavaScript that's compatible with the advanced mode of Google Closure compiler. So the Google Closure compiler can really compress and optimize everything size-wise, and it will generate then ES5 code. There are some features. For example, you can use promises and other ES6 features, but there have been experiments of because there is a mode for generating ES6 code out of ScalaUA, but usually it doesn't make sense because it performs badly. Browsers, I mean, the ES6 implementation in most browsers is still quite it works, but it's not performant. So if you want good performance, you should still, even in writing normal JavaScript, you should still use Bubble to compile it to ES5 because it performs much better for now. Okay, thank you very much.
Go through that where we go.